So today we're going to talk a little about Ceph being used in the HPC market. So first, SUSE Enterprise Storage, that's our product. It is Ceph, which is software-defined storage, and if you don't know what Ceph is, I'll fix that in just a moment. And we have a couple of use cases. The primary is backup and archival storage. There are a few use cases where it makes sense as primary storage in an HPC cluster. A very few. And one of the key features that we have is OpenAttic. We brought across from a company that was doing a premium model. And OpenAttic is a web-based GUI for Ceph storage. And that's really the value proposition we bring, is making it very easy to manage the storage environment. So let's talk about Ceph for a moment. In case you don't know what Ceph is, it is a distributed scale-out storage environment. It's an object storage underneath the cover, so you take a server, you stick a bunch of drives in it, each one gets a daemon. They're called OSDs. You're probably familiar with this in the HPC business already. You stick a bunch of these together, and then you have these monitors over on the side. They track the state of the cluster. They're following, what devices are in, what's out. And this is really important. It's out of the data path, but it's important because the clients way up here that talk native protocols, which are RBD, that's Rados block device, and the Rados protocol itself, and CephFS, they're what we call an intelligent client. Because they have a map of the cluster and they use this thing called a crush algorithm, it's a pseudo-random data placement. Okay? The key being the clients of the cluster actually know where the data is going to go, so all the computation for placing the storage happens at the client side. So what this means is as you add nodes, you're actually building a fairly linear scale as you continue to go out. So the general size for a Ceph cluster starts somewhere around 500 terabytes to a petabyte. We are working on deals today that are over half an exabyte or more. I've actually done bids on one. It was 2.5 exabytes worth of storage. So it's quite incredible how large this can scale. Some of the other interesting aspects are there are gateways. So if you have traditional storage access needs, we have iSCSI. We actually brought the very first and most scalable iSCSI implementation to Ceph. We use the LIO target, and the way it's implemented, it actually allows you to do an ALUA target that scales across multiple gateways. So it's not active-passive, it's active-active multipath, which is great. We support S3 and Swift on the application side. And then on the file side, CephFS is native. We also have CIFS, Samba, and NFS that you can use as well. Right. And there is one interesting kind of crossover. There is an NFS gateway for the S3 storage. So you have a file-based mechanism that you can dump data on the cluster in case you need to store it for a long time and access it with object later. It's kind of an interesting technology. So what we're really here to talk about, though, is the use cases. So primary storage. Very small clusters, under 100 nodes, environments where an NFS server may make sense, a single NFS server, and it's not latency sensitive. All right, some workloads we all know in HPC are latency sensitive. Those aren't really great cases for CephFS today. There's still some work being done in the code paths to make it more efficient. So typically we avoid those, but there are some that make perfect sense. We'll actually have University of Maine here tomorrow speaking at noon about their use case, and they have Ceph as their primary storage for their cluster. Okay? The most common use case is this the second tier of storage. So we see this very common. These are very large integrations. I was looking to see if we had something on the right side. I borrowed this slide from one of my coworkers who presented at a private event earlier. The use case here is you'll have your primary storage on Lustre or GPFS or BGFS, whatever, and then you have an engine that tiers it down. Depending on who the partner is. With HPE DMF, for example, we're doing some testing with cloud tiering with GPFS right now, making sure there's no issues, but it looks very good. And then there's open source packages like Robinhood that are capable of moving data around based on a policy. And what you'll do is you'll move the data off of the high performance storage when you're done with it. You know, you need to keep it around online. This is very common because you never want data to go away. You never know when you're going to need that source data or the results from the cluster, right? Depending on what kind of workloads you're doing. So in 2 years, when you, again, instead of going back to tape, hoping you don't have bit rot on the tape, it's sitting on disk, you're able to pull it off of a very deep and cheap archive back into your active store just by accessing the data. Okay? And this typically works across S3 in most of the cases we see today. So this actually points out DMF doing the work. I don't know how I ended up with 2 slides with that, but it's the basic same type of scenario. There are a few other use cases where we run into in the HPC space. Think about your home directories, application binaries, things that don't have the latency requirements. Cephfs as a distributed file system is very good for those. It's completely POSIX compliant, so you don't have worries about locking things where you end up with lock contentions, and more problematic would be different versions where you end up losing rights. That's not an issue that we have in this case. But this is the most common, and it's very frequently used to see not just this. We're starting to see other use cases where you're looking at imaging data and a few other use cases. Again, large files, infrequent use, pulling it off the cluster. So one of the key aspects of this is people look at the upstream Ceph, right? And how many of you have touched Ceph, looked at Ceph at all? Upstream or commercial?
Upstream.
Yeah, so if you've looked at the upstream, it's a little painful, right? There are about 6 billion options you can tune, and not all of them are well documented. In fact, most of them aren't. So when you start looking, you're looking for a way to implement in a way that gives you a clean design, some recommendations on the hardware, because the only way to get recommendations today is to follow Ceph users, and it depends on who's responding on which recommendation you get, especially if you're looking for offloading journals and things like that. So what we've done is we actually partner very closely with the hardware providers, and we provide reference designs and also certified solutions. So SUSE has a couple levels of certifications. There's the base server certification. It's yes certification for the server platform for SUSE Linux Enterprise. That's driving me nuts. And then there is also the certification for SUSE Enterprise storage on a solution, and that requires the server be certified, and then we take the entire storage cluster and run it through some tests. And those do things like test NIC failures, looking for issues with bonding, trying to make sure that whole stack is solid and secure. So we have certified solutions and/or reference architectures from all of these vendors today, and more are on the way. This is part of what I do, and it's a long process, as a couple of guys standing around here will tell you. It's not something that I take lightly. Give you an idea, the final step of it today is a benchmark test that takes about 5 days to run, because I'm beating the crud out of the systems, trying to make sure that, number one, someone's not playing tricks with cache. We've all seen that. That's not okay. I've been in storage business for over 20 years at this point, and that's not the right way to make it happen. Because my promise to you is if I tell you it's going to do something, it does it. So SUSE takes this very seriously, and you're going to find reference designs that are updated. And these are not these high-level papers that say, well, this is the theory around it, and have fun. It's more about, here's the quick pieces, here's how we put it together. You got to grab a paper and follow the steps. It's a step-by-step guide, but when you're done, you have the full-blown solution, and that's the goal. So I wanted to point out again, University of Maine will be here tomorrow. That's all I have in the deck to present. Any questions? Try to keep it short and sweet today, and I did well. Russ?
All right, good job. Let's give him a big round of applause.